Hello, everyone. So this is lecture for week 2, recursion, and I'm going to start with the planning for this week. So first of all, so please open Slate and check the content. So for week 2, what we have here, week 2 recursion, and also for this week we have programming practice and quiz 1, the variant. So let's get started with recursion first. And then we go through the old items in this list today. I upload a brief presentation about recursion. So what is recursion? So recursion is the process that display in these pictures attached from the internet. You see that recursion means including yourself itself in multiple times. And what kind of problems can be solved using recursion? It's a problem that can be solved applying the same function many times. And this is the advantage of using recursion in the programming language as well. I'm going to talk about recursive functions in the C programming language. So as I said, definition is a recursive function is a function to call itself. If a program can be solved with recursive functions, it can also be solved without using recursion. Then why do we use recursion? So this is a good question, and hopefully you can answer this question after this lecture. A recursive function contains two parts, the base part and recursive case. So you must understand that these parts are available for all recursion cases. And when you create recursive function, you need to create a base case and recursive case. In this lecture, we're considering calculating factorial. If you know factorial, stated as n exclamation mark, and factorial means multiplying the current number by any numbers, subsequent number n minus 1 until the last number 1 will be reached in this sequence. So 5 factorial will be 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, and you get answer 120. So how to find recursively calculating factorials? So factorial of non-negative integer n, we can write something like n multiplied by n minus 1 multiplied by n minus 2 until we get 1. And the rule is 1 factorial is equal to 1 and 0 factorial defined to be 1. So this is definition you need to know before proceed, because this will be inserted in your programming code. For example, 5 factorial, which is equal to 120, follow this pattern. When you talk about factorial of the integer number, that there will be also condition it should be greater than or equal to 0, because we don't can get factorial for negative number. So what is the solution for non-recursive but iterative solution for factorial? So this is solution right now presented in front of you. So this is simple code, factorial variable assigning to 1. And we're looping from counter from number, while counter is greater or equal to 1, we decrease the counter. And then we multiply factorial to counter and accumulate product in factorial variable. So that solution is also pretty straightforward, but we're going to talk about a recursive definition of this factorial. So how to find a recursive definition, how to observe this pattern in using recursion. So if you clearly check how we calculate factorial, 5 factorial is clearly equal to 5 multiplied by 4 factorial. And 4 factorial will turn to multiply 4, 3, 2, 1, which means evaluation next factorial will be called to the same function n minus 1. So if you check this code in diagram, you'll see recursive evaluation here. So 5 factorial will be causing multiplying 5 by 4 factorial, 4 factorial will be causing to multiply 4 by 3 factorial, 3 by 2 factorial, 2 by 1 factorial, and then you reach 1, you will stop because this is your base case. So here you have to stop, and then values will be returned from this backwards. What does it mean backwards? So we going back and accumulate. So this one return 1, this one return 2, and then multiply 1 by 2 is 2. Then 3 multiplied by 2 is 6 return. Then 4 multiplied by 3, 4 by 6, 24 return. And 5 by 5 factorial will be by 24 will be 120 return. So this demonstrates you how we are going deeply to the stack of the function, and then we unmount the stack backwards to receive accumulated result. So just definition how the function works and how we get to the answer. So in general, for any n, we can multiply factorial by multiplying n by n minus 1 factorial. So this is the formula that would be right now implemented in C programming language for us. And now it's time to check how it will be working. So we rewrite factorial program using recursive function will be looks like the following. So we are using function prototype in line 2, int factorial int. The first int means return type. The factorial inside is parameter. And we using definition for the function is here from line 8 to line 15. So first of all, we define the base case. If n is equal to 1, return 1. Otherwise, return n multiplied by factorial n minus 1. So what is here? It's here is the same function that you just define, right? So this is when function call itself. It means recursive call. But every time we calling this function with parameter n minus 1. So sooner or later we will reach this destination, right? When we get a base case. Base case, then this is the time when recursion stop. So how to call this function, how to use this function, just clearly check the main and see how we can call, for example, this function for parameter 5. So print decimal decision, decimal value, it will be here for factorial 5. So 5 will be coming here and is not n is equal 1, return 1. Otherwise, 5 multiply factorial 4 and so on. So every time we will be continuing this execution. So this is how recursive call works. And some explanation here line by line. Again, I remind you, line number 2 is function prototype. Line number 3 is main function. Here we call in factorial 5 recursive function with parameter 5 in the point A. So this is how a stack would work. So in point A, the 5 will be put into the stack. Then we return 5 by factorial 4. Then B4 will be in the stack. The next call will equal to 3. 3 will be in the stack. Then the next is 2 and 1. And when we get 1, we get return 1. This means the function will stop functioning and you'll get answers pop up from the stack in the opposite order, how they push to the stack. So in this case, we get 5 by 4 by 3 by 2 by 1, which will be returned from the stack and printed in the line 4. Okay, so what will be your assignment based on this? Just for practicing with recursive functions, you will be asked to write a recursive program to calculate the below sum of numbers. So this is kind of summation of 1 plus 2 plus 3, etc. plus 10. So iteration, you can do it, right? Just iteration using for loop or while loop or do while loop. But I'm asking you to do it using recursive functions. So please, spend the next 15 minutes with this. And after this, we will I will introduce you with the following step preparation with practicum and quiz 1 practice and quiz 1 test by itself. All right, so 15 minutes for this. Thank you so much. Okay, so hopefully you had a time to finish this problem by yourself. Right now we're going to see solution that posted in Slate. If you have any problems with this problem, with this solution, I would advise you to check solution in Slate. Let's open it right now. So right now I'm going to open this solution. Hopefully, guys, you can see it. So recursive summations, write a recursive program in C to calculate the summation. So first of all, we'll start with function. Function calculates sum int n. So the base case, always need to start with base case when we need to finish a recursive call. And base case is 0. If n is reached 0, we return 0, and we have nothing to add. Otherwise, recursive call will be like following: add n to the sum of numbers from 1 to n minus 1. So what does it mean? It means we start from n plus n minus 1. The number will be decreased by 1, and summation will be going backwards, right? Not like 1, 2 plus 3 plus etc. 10. They started from 10. So let's see how much will be printed when we compile and run this code. So the summation of numbers from 1 to 10 is 55. Yeah, so that's what it is, right? In this case, calculate sum is parameter here. We start with 10, then 9, then 8, 7, and then when the base case n reach 0, return 0. Yeah, hopefully it was clear, guys. Any questions? So hopefully you had the chance to finish this code. If not, please spend some time to finish it. Right now I'm going to talk about the rest in this week 2 content. So we have, we just spoke about with your recursion. This is factorial C file. This is solution for recursive summation. So I'm going to talk about right now about individual practice work for week 2. So this document is also available in Slate. So this document gives you a couple of exercises to practice for this week today at your convenience. So please, since you're working from home, you can do it anytime today or tomorrow. So make sure to finish it before Thursday. So what is here? Write a program, the first one to calculate area of the circle. Second exercise, write a program to read a string in lowercase and then print in the uppercase. Number 3 program is convert the temperature from Celsius to Fahrenheit and vice versa using a function declared in the header file and defined in a separate source file. And exercise 4, write a recursive program in C to calculate the summation of numbers, but this time will be from 1 to n. That's just what we did with you today, but it will be a little bit different. So that will be entered from the keyboard. Doesn't need to exceed 100. Ensure you handle invalid input in main appropriately using the input validation approach discussed in class. I will pay attention to that. If the user enter not a number, the scan will be working not properly, so you need to react somehow. And please read comments guidelines. Comments guidelines give you idea how to comment your program. This is important piece, so I just want to highlight this as well. So make sure that you are aware of this as well. Like commenting guidelines, read this document as well. Okay, so once you're done with this, you have one more piece for Tuesday. Today is one more piece to practice with the quiz. This is the link for quiz for practice. So just feel free to try this this quiz for practice using webcam and respond to Slowdown browser. This is the way you will have your quiz on Thursday, 9 o'clock. And today, that's all for today. I guess I cover everything what I has been planning today. If you have any questions, send me email, because I am available to answer by email this week. And on Thursday, don't forget to log in and complete quiz 1. Will be available on Thursday from 9 o'clock. I guess it will be window from 9 to 10, so it'll be convenient for you. You don't need to be worry about this. But quiz itself is quite short quiz. It's not 1 hour. It's just maybe about 15, 18 minutes. So just make sure that you log in on time from 9 to 10 and finish this quiz. I guess everything is covered for today. Thank you so much for your attention. Let me know if you have any questions. Just email me and I will do the best to answer you as quickly as possible. Thank you so much and have a great day. Bye-bye.